We're in sixth grade. Happy lesson 42 today. We're back at school, out of the basement. Super excited about all those things as we get rolling. Okay, hopefully you're done with the quiz on the back side from lesson 41, and you're ready to see how you did on the power-up side on the front side. Answers read like this. 1 foot is 12 inches, 1 yard 36 inches, 1 yard is 3 feet, 1 mile is 5,280 feet. 1 centimeter is 10 millimeters, 1 meter is 1,000 millimeters. 1 meter is 100 centimeters, and 1 kilometer is 1,000 meters. 1 inch is 2.54 centimeters. 1 pound, 16 ounces. 1 ton, 2,000 pounds. A gram is 1,000 milligrams. A kilogram is 1,000 grams, and a metric ton is 1,000 kilograms. A kilogram is 2.2 pounds. A pint is 16 ounces. A pint is 2 cups. A quart is 8 pints. Totally lied. A quart is 2 pints, and a gallon is 4 quarts. 1 liter is 1,000 milliliters. A milliliter of water has a volume of 1 cubic centimeter and 1 gram. A liter of water has a volume of 1,000 cubic centimeters and a mass of 1 kilogram. Water freezes at 32 degrees and 0 degrees. It boils at 212 and 100, and your normal body temperature is 98.6 and 37. The mental math would run like this. Multiplied, got $2.34. Multiplied by 100 for B. Bounces that decimal point to the right twice, 40. I reduce, divide by 5 gives me a 5. Square root of 121 is 11. 3 squared is 9. 11 minus 9 is 2. E is estimate, so I rounded 1 7/8 to 2. I rounded 3 1/8 to 3. 3 times 2 is 6. Divide by 5 is 7 times 4 is 28. Explain how to find the average of a set of numbers. Add and then divide. You want to get in more detail, add all the numbers together, divide by the quantity, or divide by the number of numbers that you add together. Start with 3 score. Score is 20. 3 of those would be 60. Add 10 to that is 70. Plus 2 is 72. Divide by 8 is 9. Square root of 3 times 5, 15. Plus 1, 16. Square root that, 4 plus 1, 5. Square it is 25. Problem solving guy said, Darla noticed that each number in this sequence is a prime number. 31, 331, 3,331, 33,331, 333,331, 3,333,331, 33,333,331. Does the pattern of prime numbers continue? Well, you got a 50-50 chance. The way your book writes it, you would probably write down yes, because it looks like you got a sweet pattern of keep adding a 3. The real answer is no. But guys, there's just absolutely no way to solve that or do that one. You would literally have to write the next number, which would be 333 million, and divide it by 7, 5, 13, 19, 17. Think of all the different numbers that you could try to divide into and see if it goes in there evenly. It would take you all day. So I don't know why they put that problem in there, because they're not really teaching you anything, because it's actually misleading, because they gave you what looked like a pattern, but the answer is no. I guess the only thing they're really trying to teach you guys is as prime numbers get bigger and bigger like that, you're eventually going to find something that divides into it, because it's a huge number. So they have supercomputers trying to find the biggest prime number yet to date right now, literally doing all the math in the background, trying to pick the next number and divide it by every other known number. Okay. So the answer is no, guys. Today we're moving on. We're starting to get heavy this week on decimals, working with decimals, and then fractions, percents, and decimals, and changing them in between there. Different ways to write decimal answers. Rock on, let's do it, okay? The new concept says, when a decimal number is divided, the division sometimes ends with the remainder of 0. The answer that results is called a terminating decimal. However, at other times, the division will not end with a remainder of 0. Instead, the answer will have 1 or more digits in a pattern that repeats indefinitely, because we in math can go on forever. It goes on forever. Here you show 2 examples. I take 43, I divide it by 6, and I get an answer of 7.1, 6666666, and the 6's will go on for forever. I take 3.5, I divide it by 11, I get an answer of 0.31818181818, and I keep doing 1/8 for forever. Okay, on the bottom it says, if we have to add terminal zeros to the dividend to carry out the division, will the answer always continue indefinitely? Yes, guys, if you keep adding zeros, it's going to keep going on forever. Okay. Terminating, guys, means it ends. So if I have 1/4 and I write it as a decimal, it's 0.25, done. It terminated. The repeating digits of a decimal number is called the repentant. In 7.166, the repentant is 6. In 0.31818, the repentant is 18, not 81. One way to indicate that a decimal number has a repeating digits is to write the number with a bar over the repentant where it first appears to the right of the decimal point. So guys, it's repeating decimals. It's not repeating numbers. And so they're going to challenge you that today, and I'll show you what they mean with it. It has to be after the decimal point, and then it has to be as soon as it starts. So there's a big difference between repeating 18 and repeating 81. You're going to say it's going to get the same pattern. Yes, except it starts with the wrong digit, guys. So make sure you do that the right way. For example, 7.1666 can be written as 7.1. The number that's repeating is 6, so I write that one time, put a line over it. 3.1818, 3.18, I write the 18, which is repeating, and put a line over it. Example 1 says, rewrite each of these repeating decimals with a bar over the repentant. Awesome. So guys, I got the first one written on the board. It's 0.083333. Okay, the 3 is repeating. So everything before the 3 stays the same. So I write 0.08, then I write what's repeating the 3, and I put a bar over it. And that's what we're doing today. The next one, I have 5.14285714285714. Do you see how they got it to the third time it's repeating to tell me this is legitly a pattern? So everything in front of the decimal point stays the same. Everything after the decimal point is repeating. So what's repeating? The 1 is, the 4 is, the 2, the 8, the 5, the 7. And then it repeats over. So guys, the bar goes over all of those because all 6 numbers are going to keep repeating. First 6, 6 again, and we just keep going. Okay, then here comes the next one. I have 45454545454545. Everything to the left of the decimal stays the same. So it's 454. And now we would be tempted to say, what's repeating? Well, 45 is repeating. But what's the first decimal point, guys? The first decimal point is this 5. So it's actually repeating 54 because we have repeating decimals, not repeating numbers. So that's an example of saying make sure you rate till the end of the decimal point. It comes after the decimal point, and it's the first number. It's not 45, it's 54. Okay, so one example of questions they're going to give you. They're going to give you the repeating decimal. They're going to tell you to write it with a repentant, or they'll say write it with a bar over it. Example 2 says, can you round each decimal to 5 places? So now they give you the repeating decimal, and they say, can you round this to a certain place value? This time they picked 5 places. So guys, to round to 5 places, I need 6 decimal places. So this looks like this. 5.123. Now what's repeating? The 6 is repeating. So I have 4, 5, 6. I start at the 5th number. I look at the 6th number. A 6, 5 to 9 goes up one time. So I have 5.3166, round up to 7. They said round to the nearest, to the 5th decimal place. I have 5 of them. Next one, you have 25.405 with a repeating over the 405. So I write 405, and I'm going to write it one more time because that's now 6 decimal places. I start at the 5th one, which is a 0. I look to the 5, up one time. I write it correctly, 25.4054, rounds up 1 to 1. That's rounded to the nearest 100,000th is what another way they could ask that for you guys when we have repeating decimals. Example 3. Now I was going to take it to different lessons we've had. We've had compare and arrange lessons with decimals. Now we're doing it again. So the first one says compare. Guys, the easiest way to compare with this is to write the next number. Now what they're trying to do is they're trying to get you to look at it and say 0.3, 0.3 equals. Okay, if I need to add a decimal point, if I need add a number after the decimal point, it's a 0. So this is 0.30. Repeating says the next number is also a 3. Now I'm comparing 30 to 33. Well, 30 is less than 33. Okay, so don't go too fast. The next question says, can we put these things in order from least to greatest? Guys, I'm going to do the same thing I did up here. I'm just going to add the next number. The x number to 6 repeating is another 6. The next number to 0.6 is a terminating decimal. It's just a 0. This one already has 2 decimal places. So now I look. Let's put them in order. I have 66, 60, and 65. So 6/10. I chop that 0 back off. If you put the 0 on there, guys, it doesn't bother me. It shows me how you did it in your head. Then comes 65, and the last one is 0.6 repeating. Okay, if you wrote 66 because that's how it helps you do it, great. So be it, guys. And you put those things in order from least to greatest. The last thing they give you is example 4. Example 4 says divide and then write the quotient with a bar over the repeating and then round it to the nearest hundredth. So here I go. I have my division problem, guys, and off I go. Decimal point straight up. 11 goes into 1 0 times. 11 goes into 15 1 time. That's an 11. Subtract is a 4. Add a 0, bring it down. 11 goes into 40 3 times. That's 33. Subtract gives me a 7. Add a 0, bring it down. 11 goes into 70 6 times. That's 66. Subtract gives me a 4. Add a 0, bring it down. 11 goes into 40 3 times. That's 33. Subtract 7, bring down a 0. It goes in there 6 times. 66. Subtract 4. Bring down a 0. Goes in there 3 times. I'm now confident that I have a repeating pattern. Did you see how far I went, though, guys? The first time a number repeats, you can't say I got the repeating pattern. You have to check to make sure that it's not bouncing all over the place. If you think of pi, 3.1415. So if I was doing pi and I started doing the division, guys, I get 3.14, and the next number would be 1. I'm like, oh, it repeats 1/4. No, keep going out till you know it's a pattern. So I like to do it until it starts the 3rd repeat to be able to get there. Now, guys, that's a lot of division, but you know you have it right. Okay, now I have to answer it 2 ways. It says, write it with the bar. So 0.1 is by itself. That's not the pattern. The pattern is 36. So I write the 36, and I put a bar over it. The next thing they told me is round to the nearest hundredth. Guys, 3's in the hundredths position. I look at the 6, it raises it up. So 0.13 becomes a 4. And I got 0.14. Okay? Back in your book, guys, now, they give you a big, huge speech about calculators and how calculators make sure you know your calculator. And so what they're getting at is calculators will take and round repeating decimals. So if I have what I call a cheap calculator, it's got like the 10 numbers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's got add, subtract, multiply, and divide, and a couple buttons that have like M, and that's it. Really small screen. That one's automatically going to round the last digit. So if I typed in 2 divided by 3, what's 2/3? It's 0.66666. My calculator would show this, 0.66666, and then boom, they put a 7 on there. And you're like, oh, it's not a repeating decimal because all of a sudden it switched to 7. It is a repeating decimal. It's programmed to round the last number in your display. And so they're just telling you that, guys. I don't spend much time on calculators because I don't use a calculator as a 6th grader. You obviously have access to calculators being online, and feel free to use them, guys. But the warning they're giving you is make sure you understand the calculator that you're using so that it doesn't get you into trouble. Okay, that's your extra credit for today. On the top of your power up, you write, know my calculator, so that you make sure you are getting correct answers from your calculator and doing those things correctly. And then, bless your heart, buy a calculator that's a little bit bigger and it's got like 50 buttons on it. Those things cost like $10 and it does fractions for you. It's worth its weight in gold because it'll do everything you need a 6th grade calculator to do. Those cheapo calculators don't do fractions. A little bit more confusing. All right, guys, I'll see you for the problems. 6, here we go with lesson 42. We're starting with number 4. It says diagram the statement, 7/9 of the 450 students. So I have 450. I'm going to divide by 9. Goes in there 5, that's 45. Goes in there 0 times. Now I got to take that times my numerator of 7. 7 times 5 is 35, so I have 350. So that's how many students were entertained. B says how many students were not entertained. Now I subtract. Total students minus the number that were entertained is 100 students were not. Number 5 says round each number to 4 decimal places. So I have 5.16666. That's 1, 2, 3, 4. I look to that one, guys. 6 goes up, so it's 1.1667. B is 5.27272. Okay, I'll try to erase that so you don't get confused because it's important. Okay, so I'm rounding to 4 places here. 1, 2, 3, 4. Look to the 2. It doesn't do anything. So my answer is 5.2727. Turn the page in your book. Number 6 says refer to the circle graph to answer A and B. How many students does the graph represent in all? Well, I know that 5 like sci-fi. I know that 9 like action. I know that 10 like comedy. And I know that 6 like dramas. So I add them together. That gives me a 15. That gives me a 15. 15 plus 15 is 30. So it represents 30 students. B says how many more students preferred action or comedy movies? So I got to take action and comedy, that's these two, add them together is 19, compared to the drama and sci-fi, that's those two, that's 11, and I'm comparing those to get 8. So 8 more students like those two types of movies than the other types of movies. What fraction of students prefer comedies? Comedies had the 10 guys, the total is here, which is 30, that reduces to 1/3. Make sure it's reduced. D, what fraction of students in class preferred action? Action was the 9 over the 30, divide by 3 gives me 3/10. So you're working at interpreting the graph and then reducing. Number 7, the coordinates of the vertices of a triangle are -6, 4, 5, 6, and 0. The next one's at 0 and down -6. And the last one's at 0, 0. So here's my triangle, and they ask me what is the area of it. So guys, this is a 6 by 6 triangle. So you can do 6 times 6 is 36, divide by 2 is 18. I like to just divide one of them by 2 now, get 3. 3 times 6 is 18, 18, and you're talking about square units because we're on a graph there. So that's a square units. Number 8. All the angles at right, see if you can figure it out. So we have an L shape. They gave you 12, they gave you 10. They gave you a 10 on the top, they gave you a 20 on the side. Okay? Horizontal, 10 plus 10 is 20. Vertical, 20 minus 12 is 8. They asked me the perimeter, guys. I didn't have to figure out those for perimeter. I could have done the shortcut, right? 20 plus 20 is 40 times 2 is 80. My perimeter is 80, and we're working with inches. I'm going to do missing to figure out what this shape of this is. So I took total times total. 20 times 20 is 400. I did missing piece here, which is 8 times 10 is 80. Because it's missing, guys, I subtract it. And 400 minus 80 is 320. That is inches squared. Okay, sometimes you divide it and have 2 missing pieces. I decide to find what's missing. Number 9, divide by 11 and write your quotient with what they ask us to do. So I have 1.7 divided by 11. Decimal straight up. 11 goes into 1 0 times. 11 goes into 17 once. That's an 11. I subtract, I get a 6. Add a 0, add a 0. Okay, goes in there 5 times, that's 55, subtract, gives me a 5, add a 0, goes in there 4 times, that's 44, gives me a 6, add a 0, goes in there 5 times, that's 55, gives me a 5, goes in there 4. So A says with a bar over the repeating, what's repeating? So it's 0.1, this is repeating, guys, 5, 4, repeating. B says round to 3 decimal places. 1, 2, 3, look to here. So that was A. B is 0.15. I look to that 5, it rounds it up, so I got 1.55. C says in exercise B, what place value did you round to? 3 place values, guys. That's the thousandths. Don't forget the THS. So tenths, hundredths, thousandths. Number 12. Make a factor tree showing the prime factorization of 7,200. You got it, Buck. So the first thing I did is broke down to 72 and 100. I broke 72 down to 8 and 9. I broke 8 down to 2 and 4. I broke 4 down to 2 and 2. I broke 9 down to 3 and 3. I broke 100 down to 10 and 10. I broke 10 down to 2 and 5. I broke 10 down to 2 and 5. B says, now please write that using exponents. So I start with the smallest one. 1, 2, 3, 4, 5. I have 2 to the 5th power. 1, 2. 3 to the 2nd power. 1, 2. Times 5 to the 2nd power. Number 15. I have 21 over 24. 21 over 24 equals something over 40. I'm going to divide by 3, guys, and make this one 7/8. 8 times what gave me 40? Times 5. So I times 5 on the top and get an answer of 35. Flip your answer key over. We're to number 20. 20 says, show 2 ways to simplify this expression. They gave me 4 and then 5 plus 6. You would have said, do the parentheses first. 11 times 4 is 44. That's way 1. Starting over, you have 4, 5 plus 6. The distributive property from last week says multiply first. So 4 times 5 is 20. 4 times 6 is 24. And now I add them together and get 44. Answers are the same, guys. Here you added and then multiplied. Here you multiplied and then added. I showed the 2 ways. Number 21, justify the steps. Okay, so they gave you 5, 6 times 6 fifths plus 6 sevenths. That was given to us. The next one is, I started with 3 numbers, guys. Now you have 6 fifths. Add that to 5, 6 times 6 sevenths. You can see how we distributed it, guys. So that's the distributive property. Then I put those together, and that was 1 plus 5, 6, and 6 sevenths. A number times its inverse gives me 1. It equals 1, guys. It's inverse. It's times 1, it's identity, and then they do the rest of the math. So distributive property to inverse property. Number 22, the price of an item was $4.56. The tax rate is 8%. Find the tax on the item by multiplying those 2 numbers and rounding to the nearest cent. So you have 4.56 times 0.08. 8 times 6 is 48. Carry the 4. 5 times 8 is 40 plus 4 is 44. Carry the 4. 8 times 4 is 32 plus 4 is 36. 1, 2, 3, 4. 1, 2, 3, 4. Decimal point. I know money gets 2 decimal points, so I start here and I look there. The 4 does nothing to the 6, so my answer is 36 cents. What our cash registers do for us automatically. Number 24. What are the missing words in the following sentence? The longest chord in the circle is the diameter, guys. It goes all the way across through the middle, which is twice the length of a diameter is twice the length of a radius. Number 26. I have 6 1/4, 5 5/12, and 2/3. Common denominators are that 12, so that one stays by itself. This one I'm going to multiply by 3 on. That gives me 6 3/12. This one I'm going to multiply by a 4 on. That gives me 8/12. Now it's straight addition, guys. 3 plus 5 is 8, plus 8 is 16/12. 6 plus 5 is 11. This goes in there 1 time, and I'm left with 4/12. Carry that 1. That's 12 now. 4/12 reduces to 1/3. So I get 12 1/3. 28, multiplication problem. 6 times 5 is 30. Plus 2 is 32 over 5. 2 times 8 is 16. Plus 5 is 21 over 8. Next one is 7 times 2 is 14. Plus 6 is 20 over 7.
Almost start canceling. 5 goes into 20 4 times. 7 goes into 21 3 times. 8 goes into 32 4 times. And I have 4 times 3 is 12, times 4 is 48. So you can see how, guys, when they make us do that, they cancel a lot of those things out. Turning the page, you got number 30. It says find the measurements of A, B, and C in the figure, then classify the angle pairs as supplementary or complementary. They gave me 40 degrees. Forms a straight line, guys. Straight lines add up to 180. Minus 40 is 140. Okay, so A is 140. This is 90. Now I'm down here for B. This is 90 plus 40 is 130. Triangles add up to 180, so I do 180 minus 130 and get 50. B is 50 degrees. B is 50 degrees. This forms a straight line, so C is the opposite of that. That's 130. So C is 130 degrees. Now I'm supposed to go back and I'm supposed to classify any angle pairs as supplementary and complementary. Okay, so this one right here, guys, that's supplementary. And this one right here is supplementary. And these two in the middle, 40 plus 50, is complementary. Remember, supplementary adds up to 180, complementary adds up to 90. So you could just write those numbers, guys. 140 plus 40 equals supplementary. 50 plus 130 equals supplementary. And 40 plus 50